Hello everyone and welcome to my channel. Here is Mahmoud Hamid, and in those tutorials I would like to discuss a very important topic that interests all of the BIM engineer all over the world, especially the BIM managers or BIM coordinator, which is the site and how to um, work on a site file, how to create a site file, and how to set site settings correctly and work with other department or other engineers, or how to coordinate between different discipline or different department. And I would cover so many topics, starting from some basics about coordination system, because it's very important to understand what exactly is a coordination system, and why there is so many coordination system, and how that can differ from project to project. I will not go deep into this topic because it's a different or it's a broad topic related to the survey engineering and GIS, but I will give you the minimum basic information that required to understand this topic. And I will also talk about the location and site in the Revit, and what is the difference between location and site in the Revit, and how to set the location, and why site is very important and crucial for so many engineers and department. And I will also talk about how to connect my model to a specific coordination system, and how to create a site file in Revit step by step, and how to connect different models into your site file. Um, what is a shared coordinates? What is the role of the shared coordinates into this process or into this workflow, and how to use them? And we will go through the project base point, survey point, internal origin in Revit, and what is the difference between each one of them, and what is the relationship between the survey point and the coordination system, and how to set my survey point correctly. Last but not least, we are going to talk about the true north and the project north, and what is the difference between them, and how to set the true north exactly for my project. All of this and more we are going to discuss in those tutorials or those videos. So let's get started. So the first question we ask ourselves is, what is a coordination system, and why there is so many coordination system, and why a coordination system is very crucial and important to have a site file. So to understand the concept of coordination system, we have to go a bit deep into survey engineering and GIS, but I will not go so deep. So I will take some shallow information about the topic and bring it to you so you can be familiar with the topic. So let's start from the beginning. You have this cute small house building. We call it in Revit a project. It is a layout. By itself, it is a layout. But it's a part of a bigger layout, which could be the neighborhood. And this neighborhood is a part of much bigger layout, which could be a city or a town. And this town or city is a part of a bigger layout, which is a country, and then the country is a part of a bigger layout, which is a continent, and so on until we reach to the biggest layout ever, which is our globe or our Earth. So we have here different layout in different scales, and all of those layout must be connected together and easy measured. And later on, I will tell you what did I mean by saying easy measured. And connected, and it explains itself because it's a coordinate system. It coordinates between different layouts from different scales. So we need a unified system that we can use to connect and coordinate between all of those different layouts and with different scales. So we all studied this in our primary school, the 2D Cartesian network, or the what's called by XY axis. We have an vertical axis, we call it, sorry, a horizontal axis, we call it x-axis, and the vertical, we call it y-axis. And the intersection between those two axes, it's the origin point, which is 0 and 0. And when you move up towards the y-axis from the origin and right, you get positive values. And when you move left and down, you get negative values. So this system is very practical and helpful. You can identify the location of specific points, but knowing the coordinates for the specific point, let's say this point it's 7 and 2, and if I told you the coordinates for a second point, you can also locate it into the network or into the system. And not only you are able to locate, you are able also to do a lot of measurements. You can measure, for example, the distance between those 2 points by this simple equation. And not only distance, you can measure areas, parameters, and angles, and everything you can, all kind of measurements you can manage through this system. So this system allows you to locate and also allows you to measure and do any kind of measurements. So that makes such a system is very helpful and practical to use in a bigger scales. So problem solved. Let's bring our map, our Earth, and let's have an origin point in the middle and apply the simple rules if you wanted to identify the length between those 2 points. So problem solved, we can do the measurements and so on. Unfortunately, it's not that simple because as we all know that Earth is not flat, it's spherical. So some people think that Earth is flat, and if you are watching this video, I'm sorry to disappoint you, but the Earth is not flat. If you still believe that Earth is flat, you might reconsider engineering as a field. I don't know. No judging. But anyways, so applying such a system for a spherical shape, it might work if you have less distortion, which means in a small spaces or in a smaller layout. So, for example, those 2 points may work, but when you have bigger layout, so this time you cannot measure between 2 points using straight lines because of the curvature of the earth. So you have no longer straight lines, you have curved surface. So this is the accurate dimension, or this is the accurate measurements for any distance. So that's why we need a different coordination system or coordinate system that can work here. We need to have an accurate measurements for bigger scales. And that's why we have the first type of a coordinate system, which is called geographical coordinate system, which is mainly consists of latitude and longitude. So any point in the globe, you can identify it, or you can locate this point by knowing the latitude and longitude for this point. By some mathematical calculations, I will not go deep into it, but by some mathematical calculations you can locate, and you can also measure between different points in the globe. And by the way, this type of coordinate system is being used in Google Earth or Google Maps, if you click at any point in the map, you will get those numbers, the latitude and longitude, and this refers to the geographical coordinates for this point. And also, it's will be used in a global or big projects when you have a really big layouts like the infrastructure projects or like civil works, those big scales projects you have to work in a very accurate measurements. So you work most of the time with geographical coordinate system to assure that you have an accurate measurements. Um, However, we still need to measure easily on paper. It doesn't make any sense to every time that I need to make any measurements to walk around with a spherical shape and do my measurements on it. And we want also those measurements to be accurate. Like I want to work on 2D, but also in an accurate way. So how to do this? How to transfer this spherical shape into a into a 2D element that I can use in paper or in any kind of 2D surface. If there is a way, of course, there is a way. Otherwise, you would see all of engineers walk around with sphere and work, do all of the drawings on the sphere. It doesn't make any sense. So here comes the second type of the coordinate system, which is the projected coordinate system. And I will give the UTM as an example. The UTM is the Universal Transverse Mercator coordinate system as an example because it's the most common and it's been used by so many countries around the world. And from its name, it's projected coordinate system, which we are talking about projection. So we are going to project the spherical shape into a 2D surface representation. So how to do this? There is so many ways to project a spherical shape, but Mercato had decided to use the cylinder projection, and I will try to simplify this as much as I can. So I want you to imagine that we have the Earth, spherical shape, and we have a cylinder, and this cylinder is consist of a mirror. We have a mirror inside this cylinder. So I want you to imagine that the walls of the cylinder from inside is consisting of mirrors that can reflect the surface of the Earth. And we put the Earth inside this big cylinder, and after that we brought a scissor and we cut this cylinder into or from half, and then we decided to spread it into a 2D surface. This is just to simplify the process and make you to understand it easy, but it's much more complicated and has much details than I've told you. But this just to simplify it. If you want to go deeper into this topic, I advise you to look further into the GIS topics. So, uh, after that, we will have a 2D representation of the spherical shape of the Earth. But any projection will have a distortion. You cannot project very accurately. You will have a bit of distortion. So Mercator decided to avoid, or to not to avoid. You cannot actually avoid distortion, but you have to minimize this distortion as much as you can. So Mercator decided to divide the Earth or the surface into 60 zones. So starting from left to right, we have here zone 1, and then we have here zone 60. And also, he decided to divide those zones by the equator of the Earth. So you will have here N and you have here S, north and south. And so for example, here this is zone 70, 17, for example, it will be 17N or 17 north, and here we have 17 south. So practically they are 120 zones. So he have done this to minimize the distortion. So if we zoomed in and we try to look into one zone in close and to identify where exactly my origin, where is the x-axis, where is the y-axis, and how to work on such a coordinate system. So for example, this is zone 17 north. So when I say north, I'm talking only about the upper part of this strip or of this zone. And let me zoom it a little bit bigger so we can understand what exactly happens here and explain a new concept. So this is the zone 17 north, so you have to forget about the lower part because I'm talking about this part only of the zone. And the origin of this coordinate system is the intersection between the center line of the zone and the equator of the Earth. This is the equator of the Earth. This is 0. And here the middle line of the zone is the y-axis. We call it here northing, and we call this x-axis by easting. But you have to know that we have the origin not at 0 and 0. Sometimes we have to have false easting to assume some values for the easting or for the northing. I want you to pause the video and ask yourself, why would you assume that the false easting here 500 kilometer? Why the origin point, it will not be 0 and 0. Instead, they decided that the 0 point will start from 500,000 meter and 0. Why would we do such a thing? The answer is to avoid negative values. So that's why sometimes we have to assume false easting or false northing or both of them to avoid negative values. Let's imagine if you have here 0 and 0. If you move to the right to the zone, you will get positive, but if you move negative of the zone, you will get negative values. And we want to avoid negative values to make an easy calculations and also to avoid any confusion or misunderstanding. So that's why they assume that the origin will start with a false easting with 500 kilometer, and that will assure that anytime I will move across the x-axis, I will always get a positive values. So what about the northing? About the northing, we already um, have 0 in the northing, and we are moving only in this direction because as I told you, this is a separate, so we separate each zone by northing and easting. And if you're working in on zone 17S south, so you will start from here. So the origin point will be here, and you will be moving also up, so you'll always get positive value for the northing. So we don't worry about the northing, we worry about the easting. That's why we assumed here false easting by 500 kilometer. Then they decided to do further adjustment. They want to minimize the distortion even more. So you have a distortion, yeah, the maximum distortion, of course, if you're moving in this way, but you also have a curvature on the other side, and you have a distortion also on the other side. So they wanted to minimize this distortion as well. So they have done some enhancement on the Mercato system, and they call it now the Universal Transverse Mercato. And actually, it was done by the military of the United States. I think it was in 19th or something like this. They decided also to contribute into this system and divide the world into also horizontal strips as well. Starting from, I think there are 24, yeah, 24 horizontal pans starting from A, ending with X. So it will be easier also to identify which zone that your country in. Your country could be in 2 zones, 3 zones, 4 zones. It depends on the size of your country. And I will give you examples on some countries that still using the local system, and some countries that has been using the UTM system, and you will get better understanding about the topic and how we can link this to our site in Revit. So you might ask yourself, why some countries still using their own local systems? So now we have a universal system. Why cannot we all use the same system and agree on one thing for the whole world? Actually, has been already done. So many countries are using a UTM system, but still some countries using their local system. And to understand why they are using their local system or a different coordinate system, I will have to give two different examples for two different countries. The first country is Germany, and the second country is Egypt, because I already worked in both of them, and I worked with different coordinate system in both of them. So let's start with Germany. Germany, one of the countries that has been adopted a UTM into the workflow and into the projects, and Egypt now working with some different coordinate system, actually the red belt and the blue belt and the purple belt. So let's start with Germany. Germany, as you can see, Germany, most like the western part of Germany in the zone 32, of course, we are talking about the north, and U is the band, the horizontal bands. So let's go back a little bit. So you can get this map in the internet. You can write UTM zones, and you will get this map in bigger scales. But as you can see here, this is the U band, and here we have Germany. So Germany is between 33, yeah, and 32, and a little bit of Germany, I think just few cities on the western side in the zone 31. But anyways, Germany, it depends where are you located in Germany, you will use one of those coordinate system. So let's say now I am in the western part of Germany. Let's say I'm in Cologne or Düsseldorf. Those cities, you will be using the coordinate system according the UTM coordinate system according to the zone 32U, which means that your origin will where is your origin will be. I want you to pause the video and decide on paper where is your where is your origin point of this coordinate system. And we agreed that we are not talking about 0 and 0, we are talking about 500 kilometer and 0. Find me this point and continue the video again. So actually you cannot find this point here because this point is the intersection between the vertical axis, which is the middle line of the zone, and the equator of the Earth. And the equator of the Earth actually is it's not shown here. So let's go back to the map. And here we have the 32U. This is the zone that we are talking about. And this is the middle line of the zone. And here is the equator. So my origin for this coordinate system will be here, exactly in this point. And the coordinate for this point will not be 0 and 0. The coordinate for this point will be 500 kilometer and 0. So you move up, you will get a positive value for the northing, and you move anywhere around the zone, you will keep getting positive values. Same for the zone 33 and 31, so the same concepts apply. Now let's go to Egypt. Actually, you can ignore the Arabic writings because it says the same red belt, blue belt, and purple belt here. So Egypt decided to use a different coordinate system and the local coordinate system, and they are using they decided to do this to minimize the distortion even more because Egypt is a relatively big compared to Germany. It's a triple size of Germany, and they want to even minimize the distortion more. Even locally, on the local side, they want even to reduce it more and have accurate measurements. So they decided to use their own coordinate system, but actually you cannot decide to work with your own coordinate system and ignore the rest of the world. You have to somehow to connect it with a different or with a global coordinate system. So they decided to divide Egypt into three parts. Actually, there are two more has been added, but let's now stick with three parts. And a part called the red belt, and a part called the purple belt, and part called the blue belt. And they decided to connect this coordinate system by using the latitude and longitude of the Earth. So the intersection between 31 and 30, they decided that this point will be our origin for the red belt. And the same for the purple belt, they decided that 30 and 27, the origin, and for the blue belt, they decided that the 30 and 35 will be the origin. So this is the origin for the different three coordinate system, but this origin is not 0 and 0. They assumed also false easting and false northing in the same time. Why? You already know the answer, to avoid any negative values if they moved down or to the left side. So they assumed bigger number here according to the distance, and they decided to do this to avoid any negative values. Same for here, same for here. They assumed also false number, false easting, false northing for each one of them. And in the same time, they are still able, if they have a global, they have a big projects between two countries, for example, they still can connect this coordinate system to another coordinate system or another universal coordinate system easily by converting from this one, from the local one to the global one. So I want to show you how actually how can we get familiar also with those coordinate system. You can browse and even convert between different coordinate system in this website. You just write epsg.io, and in this website you can, for example, let's write red belt Egypt, and let's see. And as you can see here, I found it. This is Egypt, 1907, red belt. Click on this. It gives you so many information about this coordinate system, and also you can click here on the map and get the easting and northing of any point on the Earth, but with according to this coordinate system. So, for example, I can get the easting and northing of any other countries, like for example Tunisia. Of course, I got a negative values because it's not designed to be used in Tunisia, designed to be used only inside the red belt, which is the middle of Egypt actually. If I decided to use it, I think even I can, yeah, I keep getting negative values when I go outside of Egypt, and it makes sense. But anyways, you understand the concept. You can use this website to identify any easting and northing according to the coordinate system that you're being using here. So let's try it with Germany, for example. So now let's try it with Germany. So let's try it UTM zone 33N, for example. So as you can see here, this is not the one that I want. Yeah, this is the one. So this is ETRS UTM zone 33N, which is the 33, it's the eastern part of Germany. So here again, some information about this coordinate system, and if you clicked on the map, you can get the coordinate of any point on the map according to this coordinate system. So as you can see here, if I want, we go to Germany, and we are talking about the eastern part of Germany. So as you can see here, you keep getting a positive value for the easting, but once you get out of the zone and you go a bit left, you will start getting a negative value of the easting. And the origin point of this coordinate system should be somewhere here. I think so. It might be somewhere here. And yeah, so you can play around with this website, see which local coordinate system that has been used in your country or your area, give the code or give the country and to search, play around so you can have a better understanding of the coordinate system. As a conclusion, you as a BIM engineer or a BIM coordinator or a BIM manager, you have to know exactly which coordinate system you're working with. Is it geographical or projected? And if it's projected, which is 90% of the cases actually, you have to know which zone that you have to use, which if it's UTM zones or is it a local projected coordinate system like the one that I showed you in Egypt, or it's other coordinates projected coordinate system. And if it's a UTM coordinate system, you have to know your zone, which zone that you're working with, and you have also to know the origin coordinates. Does it have false easting and false northing? What is the coordinates of the origins? And you have to know where the coordinates of the layout survey point. So you will get a layout, or you will have to create your own layout. You have to know exactly what is the coordinates of this survey points. Usually it will be relative to the origin of the coordination system that you will be using. I will explain this, of course, in details into Revit, but you have to know this now for as an information. So, after all of this information, what is this has to do with our small building here? How this all GIS survey information can relate to this small building here? This what we are going to know in the next video.